In this video, I am going to go over this organic chemistry synthesis problem where we have a benzene and a halogen here, or a haloalkane, in this reactive molecule, and in this product we have an alcohol. So now we have to think about what's the similarities and differences between these molecules. The similarities are this backbone, and the differences are going to be this alcohol and R group. When I see new R group, I think of Grignard reagents, and I know that this alcohol is going to come from a carbonyl. So when I go backwards here, I am going to say that that alcohol came from a carbonyl oxygen. So I'm going to say that that alcohol came from this ketone here, where this pink carbon here is this pink carbon here. And whenever we want to add a new R group onto the molecule, we think of organometallic reagent like Grignard reagent. So the first step here is going to be this R group that we want to add attached to an MgBr, because that is the Grignard reagent that would add that R group. And the second step is going to be acid workup to clean up the alkoxide O- ion, right? So now we have to figure out how to get this ketone from this haloalkane. So we could go backwards further by saying that that ketone came from an alcohol, and we oxidized that secondary alcohol using, let's say, PCC. Jones would work as well. So now we would have to figure out how to convert this bromine into the alcohol, which is going to not be NaOH in water because that would do E2, but we would do ester hydrolysis by first putting acetate to do SN2, because the acetate is a nucleophile that would kick out that leaving group bromine and invert the stereochemistry of a wedge to a dash, inputting that group onto that molecule, making this an ester. And from this ester, we could hydrolyze that ester using acid, water, and heat. You could have also done this in basic conditions by adding NaOH, water, and heat as the first step, and second step, acid workup to clean up the alkoxide ion O-. But that would cleave that bond between the carbonyl carbon and oxygen to get this alcohol, and carboxylic acid would be the side product here, but we are going to focus on this alcohol in order to complete this synthesis problem.